بصوا يا جماعة، احنا دلوقتي عندنا a very important topic that we're going to discuss. Or actually, Ayman is going to present. Ayman Kaheel is the CPO, CPTO, or CPO, or CTO. Yani he has the technical knowledge قوي, and he has the product knowledge قوي. His experience has been extensive throughout yani many years, if not decades, I don't know really. And he's going to talk to us about AI products. The topic itself is the science and art of building AI products. I'm really excited for this topic. It will require يعني huge amount of excitement لأن فعلا AI is the future. Please a big round of applause to Ayman Kaheel, our CPO at Breakfast. تفضل.
Thank you so much.
Thank you.
طيب مساء الفل عليكم جميعا. Before I start, can we give a huge round of applause for the folks who are organizing this conference? I think it's incredible. I'm pleasantly surprised, and I actually love that we have this kind of conference now here in Egypt. Okay. So, first, my name is Ayman Kaheel. I'm the CTO of Breakfast. I actually manage product engineering and design and data at Breakfast. What I would like to talk to you today about the unique challenges that arise from building AI products when we're building AI products. And I think this topic is actually quite interesting. So as Yue said in the morning, AI is going to rock your world. Like there is no escape. AI is changing everything about how we work. So in the morning, he talked to us about how it changes the way we do the work. What I'm going to talk to you about is what is different about building AI products from conventional software products. So let me first convince you that I know something about the topic. So I've been building AI products since 2007. I'm old. I've built AI products at Microsoft. I've built face recognition, document retrieval, search. I've built AI products at Amazon, the famous Amazon Go, where you pick up stuff and just go. I've also built AI products at Yahoo, different aspects of search. I've built AI products in my own startup, Risa, where we did investment models based on AI. I've built AI products at Cruise, self-driving cars, trying to teach the car how to see and perceive the world. And we're building AI products, of course, at Breakfast in different aspects. Although these are all different products, but the challenges are very similar. And I've made so many mistakes, and I'm hoping to give you some of that experience today. Okay, so I'm gonna touch on a few things here. I'm gonna talk about the science of building AI products, which is sort of the technical underpinning of building machine learning or AI models. I'm gonna touch about the human aspects. Ayman talked about some of that today of building AI products. And I'm gonna talk about when we combine these together, and then hopefully I'll leave some time for questions at the end. The timer is not working, by the way. Yeah? Okay. All right. So let's jump into this. So first, my presentation is very different than the presentation you've seen today. They're all pretty flashy, colorful. My slides are not flashy, not colorful. They're full of graphs, they're full of technical terms. So I apologize if it's too late in the day for that, but that's what happens. All right, so in order to level set on terminology, I wanted to just describe a very basic or conventional way of building an AI model, because that's important to understand the challenges in building an AI product. So the first thing we start with, just like any product, we need to be crisp about the goal. This is generally very important, but when it comes to AI products, it makes the difference between failing and succeeding in the product. AI products, there is a number of studies that talk about the percentage of failure in building AI products. It goes up to 85% of failure rate. So chances are you're going to fail, then you're going to succeed. 30% of that is attributed to setting the wrong goals. Let me give you an example. If you decide to build a chatbot for customer service, something that we all do or think about these days, your goal has to be very clear as a product manager. Are you building that for cost-saving purposes or for customer satisfaction purposes? Customer satisfaction purposes in the sense you want to reduce the time of the customer to find answers. Cost-saving, you want to basically replace as many agents or reduce the number of agents. These are very different goals. You can argue that one would lead to the other, but what is the goal? And the reason for that is, if you're building the chatbot to cost save, then you want the chatbot to be able to answer all the questions as much as you can. If you're trying to get customer satisfaction, then you want the answers to be perfect. So even if you're going to answer 10% of the questions. So, and that mindset goes across all the decisions that you do in AI products. So setting the goal is very important to dictate the kind of trade-offs that you're going to make. And I'm going to talk about some of these as we go. So that's the first step. Typically, you set the goal, you acquire some data that you're going to use either for training or evaluation or both. You do data annotation for conventional AI before large language models. We use data for training, so we need to label the data with what we call ground truth. Basically, what is this data represent? We build the model, very iterative process. We test the model offline. So basically, the data scientist or the ML engineer that builds the model would do evaluation or internal iteration on the model and says, hey, it's ready. Here is the model. It's ready. It does this in offline. Then we take that model, we put it online, and we test it online through A/B testing. That's the conventional method. LLM changed the game a little bit, made it much more accessible in the sense that you don't actually need to build the model. The model is there. You just need to do a lot of prompt engineering, but you do everything else. You collected the data for testing. You've done the annotation if you need, and then you do offline testing and online testing. I'm going to be talking in the general sense through the presentation. And because of that, I'll touch on things that maybe LLMs have, shortcut, but in general, the principles still apply. Okay. So the first thing you need to think about is the data sources. What are the sources of data that you're dealing with? And the reason for that is it has implications. These are two news bits. One of them is a scandal for OpenAI and a lawsuit because they're training on books by publishers that haven't given them the license to train on them. The second is LinkedIn basically training some of their models on the user resumes without actually putting this in terms of services, without taking the permission of users to train. I know laws in Egypt could be slightly looser, but I don't expect this to be for long. I expect this to actually get tighter as we go time. So the least you need to do is to understand where the data came from. Usually the machine learning engineer or the data scientist will come and say, hey, I trained the model. Here is the model. First question you ask, where is the data came from? Where did you get the data from? Someone said something today that I really liked in one of the panels, which is the PM needs to be 10 steps ahead. This is being ahead. This is not being happy with the result before you understand how we got that result. The second thing that you need to think about is also related to data, which is the bias, the imbalance, and the overall representation in the data. And the reason for that is you need to understand the risks that are associated with this data source. Every data set has limitations, every single one of them, regardless of how it was collected. The question is, what are the limitations? And as a PM, you need to understand the limitations of the data set, because the data set mandates what will you be able to get out of the model. So this is an interesting example. So again, Reuters reported that Amazon scraps secret AI recruiting tool that has bias against women. The story here is, I worked for Amazon, so I know a little bit about the story. Amazon tried to replace the evaluation of managers by an AI tool. And basically what they did simply is they got resumes of the top performers at Amazon. Nothing's wrong with that. And they trained a model that can score the profiles. It's not just the resume. They also looked at few tests that they passed to the candidates in order to make that judgment. At the face value, this looks very reasonable. The problem is, in the US, only 25% of the workforce in tech are women. So it's reasonably to assume that 25% of the top performers are women. So what does the model learn? The model learned that men are more likely to succeed than women. So basically, it started providing the top candidates as men, to the degree that it started self-fulfilling. It became a self-fulfilling loop that toward the end of the project, there were no any more women candidates. They're just men all along being filtered to the managers in order to decide which one to hire. A data limitation, a PM should have quote. The project didn't have a PM, by the way. The other thing that you need to think about is the balance of the data set. So this is a data set for self-driving cars. The task here is detecting pedestrians in the street. When you want to think about pedestrians in the street, you want to think about all the kind of pedestrians that you're going to meet, not just certain size or certain look. You want to look at all of them. Cyclists, you want to look at wheelchairs, you want to look at small kids, adults, you want to look at all of them. You also want the data set to have the negative examples, the examples that you don't want to recognize as pedestrians, like the fashion dolls, models, whatever. So this is also problematic, because if the car cannot recognize any of these, it will hit them. Straightforward. Not recognize them as a human being, just pass over. A third problem is the representation. When you put out a model like ChatGPT, you want the data to be balanced, have a proper representation of the customers or the users or the topics that it's going to talk about. So GPT-3 specifically got trained on news. So the claim to fame is, hey, we scrape all the news article of the web and we trained them. Like, it's a huge data set. It's incredible. It can answer so many questions now about world facts. Guess what? News are usually negative when it talks about minorities. So what do you get? You get things like this. By the way, this was not only about Muslims. It's the same about Sikhs. It's the same about Hindus in the United States. So again, the second thing that you need to do after asking about the source, you need to ask, what are the biases in the data? What are the limitations in the data? What are the different representation? Are we balanced in the way we're representing the data? The second topic that is part of the science of building a machine learning model, as I said, we do evaluation of the models. We do evaluations online and we do evaluations offline. One thing that we need to recognize is there is always a trade-off in the problems that we're trying to solve with machine learning or AI. You need to understand what the trade-off is. I've put 3 examples here. So one example from breakfast. Yes, I'm biased. Recommendation engines, in general, are trading off between what we call explore versus exploit. I know that Ayman is a customer on breakfast. I know what Ayman buys. What I could do is continue to feed Ayman products that she likes. Or I could start giving her products that she haven't seen before. So that's explore. Exploit is giving her what she knows, what she already buys. Nothing is wrong here. It's just you need to be aware of that basically trade-off in order to make the right product choice. It's just a trade-off. Another trade-off here is fraud detection in credit card transactions. Imagine every time you basically use your credit card, it flags the transaction as fraud. It would be pretty annoying having to call the customer service, having to call the bank. Hey, this wasn't really fraud. It was me making a larger purchase that I'm used to. That would be annoying. But also, if the bank doesn't flag it as fraud, there is a chance of money loss. Believe it or not, it's your problem as a product manager to find the proper balance in that trade-off, the operating point between these 2 extremes. The same for self-driving cars, for example. The underlying trade-off is I'm going to stop at every pedestrian that I'm seeing in the road. So someone who's standing in the road, I don't know if he's going to cross. I'm just going to stop for. And in a busy city like San Francisco, that means you're going to stop every 10 meters. Not a great experience. Comfort of the driver, the comfort of the passenger is greatly affected or negatively affected. So understanding that trade-off will allow you to figure out the right operating point for your product. Let me be a bit more concrete around this because I think this is a very important point. I told you I have graphs. So one way we measure machine learning models is through something called precision and recall. And the intention here is to have metrics that measures both sides of the trade-off. What does that mean? So imagine, let's take a very simple example. We're building a spam filter for emails, a very simple one. Precision measures how good, when you say that this email is a spam, the percentage of times it's actually a spam. Recall measures how many of the actual spam emails you're actually flagging as spam. There is no perfect spam filter out there. There is no spam filter that will give you 100% precision and 100% recall. You'll either end up with a lot of emails that are not spam in the spam folder, or a lot of emails that are spam that are not marked as spam. That is a design choice that is made by the PM that decided to launch that filter. Again, that's a typical curve between precision and recall. And so a perfect curve will get you here, like 100% precision, 100% recall. That does not exist. It's always a trade-offs. Some algorithms are better than others, so the curve might reach higher precision rates and higher recall rates together. But generally speaking, this is a very typical curve. So finding the point on the curve that you want to operate at. And that point will be different. So for example, for spam emails, you want to go for high accuracy, like high precision. When I say that it's a spam, I really want it to be spam because I'm moving it into another folder. for things like, for example, cancer detection in X-rays. You want that to be very high recall, even if you're recalling. So one question you'd ask, who's actually making the cancer detection? Like, if you're getting that answer, who's getting it? Is it the patient or the doctor? If it is the doctor, you want to highlight all the possible points of cancer. If it is the patient, maybe not, because you'll just freak them out. So all of these consideration has to go into your mind when deciding how, like, the ML engineer and data scientist doesn't really care. They'll run their models, they'll get the answers, they'll find the curve, and will hand you the curve and say, hey, here is the precision recall curve. You have to decide the parameters of the curve, the parameters of the model, such that you decide on the point of operation of the model. Otherwise, the experience of the product would suffer. The other thing is, models are never perfect, and iteration will never finish. It's probabilistic in nature. You can keep iterating on the model forever. You can keep improving on the spam filter for decades. I'm not joking. And you'll not reach perfection because it's just statistical in nature. So you get, as a product manager, you get the honor of deciding when to stop. The important point here to understand is, as a user of a product, I don't care about the model accuracy. I care about the system accuracy. I care about the value that I'm getting from the system or the product. So that means I could do things to increase the system accuracy, even if the model accuracy is not that high. For example, by using heuristics. If I have a transaction more than 100,000 Egyptian pounds on the credit card, I'm going to stop. That's a heuristic. Another possible heuristic is when we were doing self-driving cars, for example, if I see a car size that is bigger than a normal passenger car, that's a truck. It's a very safe heuristic. And another way to do this is you add other models. So you have a model to detect fraud for small transactions. You have a model to detect frauds at medium transactions. You have a model to detect fraud at another level of transactions. You could have multiple models voting on the result. By that, you're just increasing the overall accuracy of the system. Not necessarily the model, but the overall accuracy of the system. That is an engineering way to get around the accuracy of the single model. And also there is the notion of human in the loop. So, for example, in Amazon Go, when we see something on, everything in the shop of Amazon Go is automated with cameras. But if we see something that we don't recognize on the floor, we don't know if that's actually inventory piece, if it is, something that needs cleaning, we actually don't know. So what we do is we kick it to a human who's sitting in a knock that looks at the picture and say, oh, this is a can of beans on the floor. So you could do that too. So again, the point is, as a product manager, you need to decide when enough is enough and when it comes to iterating on the model. The other aspect here is in evaluation is offline versus online. The offline evaluation is great. Like the engineer, the data scientist will give you the model and say, hey, this is a 90% precision, or this recommendation engine outperforms the older recommendation engine. You need to understand how much this actually correlates with online results. Meaning, so in a spam filter, most likely if they tell you that the model actually gets 90% of spam, most likely when you put it actually online and test it in an A/B test, you'll get the 90%. But in recommendation engines, they could work forever in improving the quality of the recommendation, and you get zero improvements in the product because there is no correlation between offline and online results in recommendation. How many of you have heard about Netflix $1 million recommendation competition? Good, some people did. So Netflix, at some moment of time, put out a competition, put a price of $1 million for the best performing algorithm for recommendation. And they had an offline kind of metric to evaluate which model is better. And they did that. The team that won was a collaboration between Stanford and UC Berkeley, and they got amazing results. And then they put the model in production, didn't do anything. Because basically, humans are different. So let me not go there. So basically, there is no strong correlation between offline and online results and recommendation. Why is this important to know? Is let's not test recommendations offline as much. If it works, if it just works and looks reasonable, let's put it online for an A/B test and see if it's going to improve or not. Otherwise, you're just losing time and losing on the chances that actually works. Offline evaluation, as I said, like stuff like precision recall, cumulative discount gain, stuff like that, DCG for search. Online evaluation is basically clicks, conversions, conversion rates, session success rate, all of that. All right. You also, and this is debatable, like I've had so much debate about this with my PMs, but actually I'm a strong believer of this. I believe PMs need to understand how the model works. How the model works in the sense, like, what is it trying, like, how is it using the data to predict the outcome? Not necessarily the features, not necessarily the structure, LSTM or whatever deep learning model that you want to use. It's more of how is it making the inference toward the result. The reason for that is sometimes, again, data scientist and ML engineer will care about getting the right result. They don't actually care about how the inference was done. So in this particular bit of news, health insurance company built a model to detect high-risk patients. And the reason they wanted to detect the high-risk patient is they wanted to classify them as eligible for premium healthcare. Pretty important. What they did is they looked at the way, like, the model was working. It looked at how much the patients were spending on healthcare. So when they looked at how much you're spending, the inference is, oh, these are high-risk patients, then these guys are premium, and they require premium healthcare. Problem is, poor people don't have the money to spend, so it had a bias toward Black people in the US because they mostly live in communities that are poor. So just trying to understand how the model works allows you to mitigate a lot of the risk that is associated with the model, even if you get really good results. All right. So the other part I want to talk about is some of the human-centric aspects of building models. Ayman talked about a very important point, which is UX design for agents. This actually extends beyond agents. In general, people are skeptical toward AI models. When they know that this is an AI model, they're very skeptical toward the results. What you need to do is build the experience around it to inspire trust. But not only that, you need to understand the limitations that are associated with the model and build the experience to take into consideration that limitation. So, for example, Netflix today in the recommendation, they say, because you watch X and Y, here is a bunch of stuff that we think you'll like. Do they say, we're sure you'll like it? No, because they know the limitation of recommendation engines. Stuff like degrading gracefully. Like when you don't actually know the answer, degrade gracefully. Say, I actually don't know the answer, or I don't understand your question. Can you explain more? Can you give me more detail? The other thing is establishing a user loop. that would gain the trust of the user. For example, a way for the user to say, I like this result. When we recommend a product at breakfast, we should have a button that says, I like it, I don't like it. It does two things. One, allow you to collect feedback, but two, allow the user to feel he's part of this discussion. You're not just shoving things in their face as AI goes. I won't talk much about this. Ayman covered a lot of that, so just jump to the next one. Okay. One interesting aspect in building AI products is team interactions. So you now have, usually in any team, you have software engineers, you have the product managers, you have designers, but you also have this additional member who's either an ML engineer or a data scientist, depending on what your company calls that person. That person is slow because the nature of building models is just iterative, it's slow, takes time, it has a lot of uncertainty. So you actually can't tell them, okay, tomorrow morning, tell us what was your progress. That would be ridiculous. That's a waste of time for everyone. So you have to be very careful how you integrate that person in your daily rituals or weekly rituals. There's also the notion of it can work for a week and get you nothing at the end. I'm not saying that that's fine, and I'm not saying that you shouldn't manage that, but you should be aware that that is a possibility that you can deal with, that you should deal with. One aspect here, I don't want to go into a lot of details here, but there is a difference between you being an AI or a PM who's building an experience that uses AI versus if you're a PM that is building AI products. For example, if you're building a search engine, it's a very different story than you're just using a search engine in your product. Because if you're building a search engine, you'll be required to put a roadmap for the search engine. But if you're doing the experience, don't even try to put a roadmap. Don't tell them, have you tried these features? They probably know their job much better than you. And it's going to be similar to you telling the engineer, did you write this in a line of code or 2 lines of code? The only way, in my mind, to mitigate the risk of building AI as a team is to be hand in hand every day, even though you don't expect the ML engineer and data scientist to report. The reason is, one, allows you as a PM to be 10 steps ahead, so you can mitigate all the stuff that we've talked about so far, but also helps the UX designers to understand what do we need to build around that, given the limitations that we're seeing, the challenges that we're seeing, the accuracy that you're probably going to come to. So strong alignment between the team members is important. There's also an aspect that I've never thought about when I was building software products before actually integrating AI, which is ethical considerations. There's so many things around this across the internet, so I'm not going to go talk about this a lot. But generally speaking, you need to provide the user with some transparency on how you're using their data. Because we've seen the news, we've seen the issues, but also from an ethical point of view, you can't be using the user information for your own benefit or your own profit without at least acknowledging that you're doing that and give the user a choice to use your product or not. That's a completely ethical thing when rules doesn't exist. European Union have very strong rules around this, but the US doesn't, and the Middle East definitely does. The other thing is, if you're building, for example, something like a recommendation engine for content, we're really good at basically discerning if the content is for adult or not, but stuff in the gray area is problematic. And not a lot of people are actually good at it, even YouTube, even, most of the famous platforms, when it comes to racy content. So part of being ethical is, for example, when you're dealing with kids on the platform, is to dial the gray area all the way to the safe area. Be very safe in the content that you're producing for kids. Again, part of ethics, not part of rules. And the last one is understanding the societal impact of building your product. So if you're working on a recommendation for news, for example, the same thing that happened with Facebook, it's a whole lot of discussion. If you keep feeding one point of view to the user, what will happen is you're going to feed more of the stuff that they like. And so you're building a loop of enforcing that point of view. And now you're basically splitting the society around opinions because you're just trying to get more engagement, and the user will be more engaged with their content. And that could incite hate, that could create division. So just understand that when you're building your products, and either deal with it in a direct way or be transparent about it. Okay, so aspects that bring these two together. I said that the model building process is slow, and that's true. Building a good model usually takes time, except maybe if you can do it with ChatGPT now, or use ChatGPT, or any of these LLMs today. One good practice that I found as a product manager is to ask the data scientist or the ML engineer to build a heuristic model, basically a rule-based model based on the nature of the problem. Like, we want, for example, to recognize pedestrians. Let's put boxes around objects that has sizes similar to pedestrians. Two things happen when you do that. One, or spam filter, for example, if something doesn't have content or has gibberish content, mark it as a spam. Two things that happen when you do that. One, you understand the problem better, so you're creating intuition around the problem. And two, you can get feedback really fast. You get a baseline, you say, okay, with this simple heuristic rule, I can get 30% accuracy. Great. I know how much headway I have, and maybe I could invest a month to get a little bit better than this and maybe stop at 60%. Versus if you get 2%, say, okay, this is really hard. This is going to take a lot of time to get to 60%. Once you do that heuristic, start again by building a simple model. There is the general, yes, thank you. The general intuition of data scientist or ML engineer is, let's do as any technologist, really, I'm not knocking on them, is let's build the state-of-art machine learning algorithm that has 100 layers deep and uses so many features to get the result done. Problem is, training that model will take forever. Not the training itself, just developing that model will take forever. So start with the simplest model ever. Think about the simplest technology that you can use to build the model, build it, learn from it, and iterate on it till the point where you feel, okay, this linear regression is not going to take us further and I need more accuracy. Maybe I can go and start building something a little bit more complex like an LSTM. Also know that as your model complexity increases, one, you'll need more data to train the models, but also you'll need specific labeling guidelines. So initially, when we do the data annotation that I talked about, engineers or data scientists are good producing the first initial draft of the labeling guidelines, like how do we annotate the data. But when you need something more specific, I usually find that PMs need to be involved in writing the labeling guidelines in order to move the model forward. So basically, manage risk by iterating fast and build from simple to complex. Don't start with the complex. I mentioned this early on, but generally speaking, as a PM for any project, you define success criteria. It's not different in AI products. You also have to be clear about the success criteria. But success criteria here is not the model metrics. Success criteria is the business value that you're trying to create. If you simply use a model for recommendation that gives you 0.01% improvement in engagement, really the business doesn't care. They care about average order value. They care about the basket size. So you need to map that to that in their mind. So don't talk to them about model. Actually, do talk to them about the model, but they care about the success in this form, and you need to define success in this form, business map. In general, it's a good practice also to balance innovation with reliability. So ChatGPT, for example, when it came out, it's dialing up all the way to innovation. It was innovative, it changed our minds of what is possible, but it also had a lot of hallucinations. And it wasn't reliable. And we all thought, okay, just like you were saying in the morning, when we first saw the model, we said, yeah, fun, yeah, I'm not ready yet. Versus if they dialed the innovation a little bit and constrained it to some domain, maybe we've all have jumped into that boat much earlier. One other thing is, it's not surprising, but I actually find that people get surprised with this. Models also need to be maintained. You can't just build a model, put it out in the wild, say, see ya. You need to maintain the model. You need to retrain it. You need to retune it. Otherwise, you get in trouble. So this is actually a very funny story. It's not funny, but I find it funny. So Zillow has, the way that Zillow works is they put out something called Zestimate, I think. It's called Zestimate. So basically they look at the house, they look at all the documents, they look at all the information, all the history, and assign a value on that house. And traditionally it has been really, really good estimates. And actually it moves the market in the US. So what Zillow started is, okay, since we know the value, we actually believe in the value that we're generating, we will buy your house at that value. So if you want to sell your house and we estimate that your house is $1 million, we'll pay you the $1 million and take the house because we know we can sell it. Or we will buy it for slightly cheaper and sell it. They put the model out. The model was working great. They forgot to continue to train the model. So what happened is during COVID, the prices of housing in the United States have plummeted. They continued buying houses at the estimate price. So after a while, the CEO found that he needs to fire 2,000 jobs, and he had to report the biggest loss in the history of the company because no one cared to maintain that model. That's an extreme example, of course, but that's what will happen if you don't maintain your model. So you don't build an AI model and integrate it in your product if you're not willing to maintain it. That's the bottom line. And this is the fun part of a product manager job, managing stakeholders. My team knows this really well. This is more trickier than in conventional software, because in conventional software, they tell you how long this will take. You say, it takes a couple of weeks and be ready. Now they come to you and say, how long this will take? You say, I really don't know. Like, what do you mean you don't know? Well, the model iteration, it's probabilistic. We actually don't know if it's going to be successful. It's fun. It's really fun working with stakeholders for the first time around AI models. So what you need to do is you bring them in your world. You have them suffer like you're suffering. Explain how the model works. Explain to them the model limitations so they're not surprised. Tell them about all the risk factors that can come with the model, with the data that you've chosen to train, all of that. And explain the trade-offs that you're making. Remember the precision recall and the point of operation that you've chosen? Explain that. Because maybe you'll have a debate. Maybe they'll tell you, no, actually, I want very high recall. I don't really care about precision. So these debates are important when it comes to talking to your stakeholders. All right, just in time to wrap up. So I think in summary, what I'm trying to tell you here that the uncertainty in AI products is much higher in software projects when it comes to time frames, when it comes to deliverables, when it comes to quality of deliverables. Your job is to narrow the band of the uncertainty across the lifetime of the project and after it actually ships. You need to identify risks, understand where the risks are coming from. You need to mitigate them or put strategies for mitigation. And you need to educate the stakeholders on all the trade-offs that you're making during the lifetime of the project. And with this, I'll end and I'll take questions. Sorry. هيجيبوا لك مايك. اوكي سوري
سوري رفع ايده قبلي، انا اسف. الاول شكرا لحضرتك. to the point, very informative. عندي سؤال بخصوص maintaining الموديل. هو سؤال نسبي شويه، حابب اعرف رأي حضرتك فيه. يعني دلوقتي في مودلز شركات كتيره كانت شغاله ان هي بتطور فيها، في ظل التطور السريع بتاع الاي اي ممكن يبقى في بروفايدر يعمل السيرفيس اللي هم كانوا شغالين فيها لمده سنتين، هو طلعها النهارده فور فري اوبن سورس. فهو السؤال هنا، امتى ابيفت واستخدم الحاجه الجديده اللي نازله بدل اللي انا شغال عليها بقالي فتره؟ لان انا لو فضلت ستوك في اللي انا بعمله ممكن يبقى اوت ديتد، ممكن ما اوصلش للبيس السريع اللي ناس تانية بتقدمه مثلا اوبن سورس او واتس ايفر. وامتى ابرسيفير افضل فيه؟ يعني ديسيجن يعني بس.
good question. بس ما ده زي كل حاجه تانية في السوفت. I'm sorry, switch to Arabic. That's like everything else that you do in software in general. It's always the decision of buy versus build. So, for example, when you try to build libraries and you find that other people have provided much better libraries in terms of performance or cost, that is also a point where you need to ask, should I continue investing? Should I consider it some cost and just move? And it all depends on the willingness of you or your organization to continue investing. It's number one. And number two, is this a core thing for you or not? Like, it's not. If it's not core, then there is a question, why are you putting your resources here when you can get the solution for cheap? Just go and put it somewhere else. So I don't think it's different for AI versus others, but maybe what you were saying about the pace is true, that the pace of AI improvement is phenomenal. We've not seen anything like this. At least I haven't seen anything like this in my lifetime. So there is a question is, why would you invest in something that is marginal, that wouldn't give you the core value that you're trying to create as a company?
شكرا.
Enough. Mike, yes.
Here? I'm sorry. Okay. May I? Here. Hi.
Oh.
Yeah.
Sorry.
So, two questions similar but different in context. First of all, in the lack of having solid governance and rules like legal, what is the rule of thumb, okay, for us here working with the national or international?
Don't do evil.
I'm sorry?
Don't do evil.
No, that's fine. That's by default. That's by default. That's a prerequisite anyway. But what's the rule of thumb to putting guidelines for governance and data policy? That's one, to make it simple, especially in the early stage when we're building small validation points. I have some things like principles of not doing evil that I will not say it here. Of course, it's your call. The second question is about also when to decide using a heuristic model like rule-based when it's simple. It makes sense to take this approach in the early stage as well. But when it's also in the early stage better, what's the rule of thumb to decide when go where in the terms of validation and having clearness of, is it viable? Is it feasible? Yes, it could not be feasible if it's not heuristic because it's much simpler like rule-based. But maybe this is the approach that will make us validate the product right way. So how to decide this and that for those both? Thank you.
Okay, so for the first questions, I think the most important part about this is being transparent with your customers or users. Like here is the set of operating principles that we've designed or guidelines that we've designed for ourselves and we're adhering to. And that will evolve with time, with customers, with users. And I personally believe that regulation in Egypt, for example, is going to change. It's like a mandate. So do look at what other countries do, other places do, put something that is reasonable and be transparent about it. And as they evolve, you'll also have to evolve. I don't know if that answers the first question. Okay. Okay. The second question is, my rule of thumb is if you can do without an AI model, do without it. Because again, it's harder to build, it's harder to maintain, higher uncertainty. So if you do a heuristic and it gives you 90% of actually what you need, stop there.
Yeah,
Don't do it.
that's what I've been saying, and I wanted to hear it from you. Thank you very much. Thank you.
هنا أسئلة. هم الظاهر هنا ناس. ماشي. اوكي. اتفضل.
Okay. My question is like not a technical question. It's more.
علي صوتك بقى.
Okay. My question is not a technical question. It's more philosophical. We'll say. Do you think we will reach to the AGI soon, or it's no? Please.
I don't think I'm qualified to answer this question, to be honest. Like, my thoughts are, we will have a lot of specialized models, a whole lot of them, that will start feeling like we have general intelligence.
Ayub. Okay. Firstly, thank you for the talk. طيب هو الناس سألت على حاجات، أنا كنت هسأل على حاجة سبيسيفيك بقى، يعني أنت يعني جاوبت عليها في التوك وفي أسئلة الناس. currently أنا بعمل بيلد البرودكت B2C، يعني مش محتاج AI دلوقتي، بس at some point I will need AI for recommendations. فسؤالي أنا في الديفلوبمنت فيز دلوقتي، هاي يعني should I consider ال AI models من دلوقتي، ولا لما بعد ما أعمل برودكت ديسكفري ولانش أبدأ أفكر في ال AI؟
It really depends on your product. It really depends on the product. So let me give you an example. So why at breakfast recommendation is important in my mind? We have 7,000 SKUs on the product. It's impossible to discover without us servicing things for you. So that's why it's critical for us. If your product, if it's an e-commerce product or B2C product that doesn't require to help the user with discovery or help the user with figuring their way around the app, so maybe recommendation is not the most important thing for you. Maybe. It depends on the app, it depends on the purpose, it depends on all of that. My point is, actually, if you can do without AI, do without AI for the longest period you can. Until the point where you think it's actually going to add value to your users and your company, only then invest. Don't do it just because it's a nice hammer that everyone is using. You learning AI is important, but you using it in your products might not be the most important thing.
Thank you. Question in retrospect.
In
retrospect.
Yeah.
Before so nowadays AI is becoming less and less times used, and it is now said as Gen AI because LLMs are becoming too available. So too available in the sense that people use it to solve simple regression problems, for example. And LLMs, in a sense, it has a huge backlog of biases, and it is their results are skewed to where they are coming from, to the productor,
to how they were trained.
Yes, yeah, of the LLMs. So question one, how can we raise awareness about not using LLMs as by definition AI. And a small follow-up: is there any chance that we create our own LLM in the MENA that we can use safely? Thank you.
So for the first question, I think I want to say this very quickly. The rush behind LLM is a hype that is going that's going to be reduced with time. LLMs will continue to be important. It's just the rush of LLM, Gen AI, all of that. It's definitely a leap forward in our technology, and we're all going to benefit from it. But the news hype around it is overhyped, for example. So I think we'll use it, we'll make use of it, we'll continue to use it. It has its own place. It's going to get better, and it's going to actually become less biased with time. But in general, I think it's just cycle of technology. For your second question, what was the second question?
There is a chance that it's going to be an LLM.
I mean, the models are you can take Llama, for example, and train it and be really good. And there are people who are doing that work. Actually, there's Dr. Hazem, I don't remember his name. If you could connect with me on LinkedIn, I can send you his name. He's actually working on an Arabic LLM. So there are people who are working on things like that today.
Thank you so much. So much. Really appreciate your time. That, Ayman.